All right, taking a look at the Chapter 5 teamer. We've got a function f defined on the closed interval from -5 to 4. And it consists of 3 line segments as shown. So we could write those lines. Let g be the function defined by g of x equals the integral from -3 to x of f of t. And so part A says find g of 3. So, in the part of like making it as easy as I can, I would write g of 3 equals the integral from -3 to 3 of f of t dt. So what does this mean? We've known that this means the area from -3 to 3 underneath this function. And the nice thing is that's just a couple of triangles. The area of this triangle, 1, 2, 3, 4, 5 times 4 divided by 2 should be 10. And the area of this one looks like it is down 2 over 1, down 2 over 1, so down 2 over 1. This should be -1, so my answer should be 9. And that problem was worth 1 point. Let's keep looking. On what open intervals contained from -5 to 4 is the graph both increasing, is the graph of g both increasing and concave down? So g is increasing when g prime is greater than 0. And here's where I would write g prime of x equals f of x. And why would I write that? Because of the fundamental theorem of calculus. If I'm taking the derivative of an integral, I get what I had. And I don't have the chain rule part because it's just an x there. So we've spent time labeling graphs. Where is this graph increasing? And that was, a pre-calculus concept. But g is increasing when its derivative is positive. Its derivative is positive when this graph is positive. So all of those parts would be when g prime is increasing, except for probably where it's 0 right there. Where is g concave down? When g prime is less than 0. What is g double prime? That's equal to f prime. F prime is the slope of f. So when is the slope of f negative or going down? So then I can draw, this is going down there and going down there. So that's where my positive decreasing match. So my answer would be from -5 to -3 and from 0 to 2. And my justification would be the stuff I did right here. G prime of x equals f of x, and f of x is positive from -5 to 2. And g double prime is f prime, and f prime is decreasing on those places. And this is where they match. The function h is defined by, h of x equals g of x over 5x. Find h prime of 3. So we've explained a little bit in class, like the AP test doesn't say find the derivative of this function. They'll say something like find the derivative of this function at 3. So this is almost as straightforward a question as they could ask, I feel. And in Chapter 5, we did the quotient rule. So again, try not to make things too hard on yourself. Don't try to make up functions. Just start writing. What would the derivative of h be? And if this is h, we've got to do the quotient rule. Or the product rule with a -1, but that would involve a chain rule. I think your quotient rule is probably the best bet. So low d high minus high d low over low squared. Outside. And then we can start plugging things in. If I want to find h prime of 3, I want 5 times 3 times g prime of 3 minus g of 3 times 5 over 225, or 15 squared. So now I've got to know what is g prime of 3 and what is g of 3. And you'll notice they do this a lot. They've already asked us what g of 3 is. G of 3 was 9. So then I look at my graph. What is g prime of 3? G prime of 3 should equal f of 3. F of 3 is negative 2 because of our slope. So throw that in there. So 15 times negative 2 minus 9 times 5 over 225. I think I get a negative 1/3. Nice. And then finally, on this last problem, the function p is defined by p of x equals function f of x squared minus x. And for the third time in this test, I'm going to say try not to make it too hard on yourself. The function p is defined. Find the slope of the line tangent to the graph of p. So everyone knew to take the derivative of p. So take the derivative of p. If p is f of, the derivative of p is f prime of. And then they're basically asking us, do you know the chain rule? So in C, we did the quotient rule. In D, we're working on the chain rule. And if I want p prime of negative 1, I can start plugging it in. That means I want f prime of 2 times negative 3. And I look up in my graph. What is f prime of 2? Here's 2. That's a negative 2. So I have negative 2 times negative 3. My answer is 6. I think the kids who got part D wrong were, really trying to do too much. And if you have a question on why you can't just plug x squared minus x in, because some of us tried to say that this function was, I think, 4/3 x plus 4. The reason that you can't just put it in there for negative 1 is, if you think about it, it's not really asking about f of negative 1. It's actually asking about f of 2, isn't it, once you put the negative 1 in there. And that would be the reason that you can't just put in x squared minus x into that 4/3 equation.